Howdy everybody in YouTube land. In this video we get to talk about the Toshiba T1000SE. Now this one I picked up at a really good price. Wasn't cheap, but it also wasn't expensive. It was, it was okay. So anyways, the condition of this thing and operability of this thing is 100% unknown. I went ahead and just popped the battery loose. So we can, that way I don't, snap it back in there because this battery is very hard to get out. This battery looks like it's a remanufacture or a custom something or another. But anyways, so the history of this machine is unknown. It came from an e-waste recycler. And there's not many videos on YouTube of the T1000. There's a handful of them, but there's none in particular about the SE. And the SE is kind of the middle of the road because it's better than the original, but it does not have the hard drive expansion unlike the LE or the XE or whatever it is. Those are the ones that you see the videos on a lot, and those are the ones that seem to be the more popular ones. But we'll get to how we're going to alleviate that one later on. But in the meantime, I don't know the operational condition. What I do know is that the power supplies on these are known for capacitor spooge. So that's going to need taken care of. But this is kind of a cool little feature. No idea what that's for. But so the screen's in good condition. The keyboard's in good condition. There's a little bit of key wear. Nothing crazy. And it types fairly well. Not bad for a rubber dome keyboard. Also, this disc I've had since my early childhood. It's no good, so I can do it for this. It won't. It's like the floppy drive is completely jammed. Won't take a disc. So we're going to have to do something about that. So that's going to be part of this whole episode. So let's see. On the back side, we have the serial number. It's kind of sticky, but it's not really that bad. Brightness and contrast on that side speaker. We have a docking port here. Then under this, we probably have the serial and parallel and VGA, which I don't even know if this has VGA, because I think this is an 8086 XT class machine. Nope, no VGA. No modem either. So, a little bit dirty. Nothing crazy. It can clean up, I'm sure. And there's a fear that this thing actually might be painted. But I don't know. Looks like we have a memory door here. What kind of memory we have in this? Oh, it's got a RAM card installed. Oh, that's about as Japanese as they come. Anyone can read that? I certainly can't. I can read that though. 2 megabyte Dynabook RAM card. So I'll leave that off to the side for right now because I don't need that at the moment. A little bit dirty. Okay, so instead of just simply plugging this guy in, you can see where it's been apart once before. Someone's really had a go at it. I think someone's been trying to fix it before me. And yeah, that door is completely jammed. So I got to figure out what's going on there. So someone's tried to fix this before me. So I don't know what kind of goodies I'm going to find inside. But I'm not going to just power this on or attempt to power it on and plug it in. I'm actually going to take this thing apart because I want to inspect it. And I want to see how much of a quote unquote mess the logic board is in. If we have some problems with capacitor juice everywhere. So alright, I'm going to go ahead and crack this guy apart and see what we got going on inside, because why not? Alright, so after taking all the screws out and then grabbing my spudger tool and popping these 2 clips down there, I can lift this keyboard up and out of here. Oh, that's an interesting observation. So we have there's some work been done on this machine. So this processor has been fiddled with. It's been replaced at one time. That has been replaced at one time, or factory rework. It's hard to say what happened there. Yeah, 1990, 1990 date codes. These are all 1990s. 1990, 94 or 92. So this has been replaced. I don't know if that's the ROM or what it is. I have to look at the service manual to know that for sure, but yeah. Anyways, the other interesting observation is we have this really big Varta bomb. And this is probably just the standby battery. So when the machine, you could probably put the machine into standby and swap the main battery without losing your state. And this is what keeps that memory, pretty sure. So anyway, it's time to pull this keyboard ribbon out so I can get down to this board without risking damaging anything. That's a gate array. A lot of these are just gate arrays. These two are identical. Actually, all three of these are identical. 4 of them. Because this one's also yeah. 1G11A. Nope, that's not it. 10G14, 11. These three are identical. This one's different. There's a couple of oscillators in a weird, strange form factor. Because typically I see them in 4-pin form factors and not 8. So that is certainly an interesting observation. There's a ROM. That's for sure a ROM. And then it has ROM expansion here and here. But I can actually expand the RAM. So I could get... This is probably 1 meg on board. This is 4-bit memory, pretty sure. So 4, 256, 5. There's 1 megabyte at 4. Actually, 1 megaword at 4 bits, and another megaword at 4 bits. So that's 1 megabyte. 2 megabytes here. There's 3 megabytes. I can populate these and have a total of 4, which 4 is insane for an XT class machine. Hell, just 1 is kind of insane for an XT class machine. So I'm not even sure how it presents itself to the system. MMS or XMS memory, and not, I don't know, EMS. So anyways, we have that standby battery, but we also have a second battery here. That's an interesting observation too. Memo power, rechargeable. And it's not Varta, but it's also just as old, 1990. So I'm removing this so we don't have any leakage potential. So that's gonna go bye-bye. I might even get another one of these. But honestly, I don't really care so much. Not really cared. What is that? I don't even know if you can buy these big stick batteries anymore. I don't think so. Not important. Because the amount of times we're going to use this machine and need a battery like that is next to none. I might pull this out once in a blue moon, play with it, and then it's going to sit on a shelf for 5 years. Because that's just the reality when it comes to retro computing in general. Some people might, play their DOS games and stuff like that, and that's fine. But for me, it's all about having fun tinkering with repairing the board. This one looks like it's in inversely. See that? It's backwards. What's underneath it? Huh. Yeah, there's nothing there. But it's funny how it was in the wrong way. Not wanting to come out. Figure out why that is. Oh. Huh. There you are. Hiding in plain sight. This is the modem cavity here. Now the cool thing is, pretty sure that these connectors are somewhat known. I was looking at the service manual for this machine, and this is basically a small expansion of the ISA bus. It's only got 3 address lines. So I wonder if I can put a 16550 here or a 16450 UART, and the machine will see it, and then maybe stick a Y modem right next to it, so I can just, that would be kind of cool. Just hide a Y modem in there. That way we can get this thing on the internet to some capacity. Because a machine like this would be ideal for a Y modem. Alright. Okay, so we're loose now. Huh. Oh, yeah. You can see it. Oh, look at that. It's wet. See that? Ooh, smells like fish juice, too. Look how wet that is. She's a leaker. She's a leaker. Not surprised. Not in the slightest. So, this motherboard has to come out. And it needs a recapicide. Now, what I don't know is what it looks like up inside this screen. Oh, there's the inverter board. Don't know if it's leaking or not. Oh, yeah. You can see it. Wow, you can see it. Yep, that's going to have to come apart. I want to save you for another time. I want to see why this thing is jammed. Oh, God, it's one of those citizen drives. Pain. Yeah, it's literally just jammed. And the thing about this machine, since this has no hard drive or expandability for a hard drive, there's no way to use anything outside this floppy drive unless you put a Gotek in here or something. But yeah, you can see it. Look how stained the white sticker label is. That's all cap goo. Every bit of that is capacitor fluid. Oh, nasty. So, in case anyone's not aware of, this is the DC-DC converter section. That generates your 5 volts, 12 volts, negative 12 volts, negative 5 volts, 3.3 volts, if there is a 3.3 volts on this system, which I don't think there is. This is the connector for the modem. These are obtainable too. You can buy these still, luckily. Now, unfortunately, the service manual to this machine absolutely does not have a schematic. So there's no schematic available for this machine. But I don't think for what we're doing that we actually need one. And if we do, well then I guess we'll just have to figure it out the hard way now, won't we? Oh, this thing smells like fish. Bad. Yeah, it does. It's terrible. Alright, there's the floppy drive. Oh, we got some surface mount doubly dooblers in there that are going to need changed. So we're definitely going to have to service this floppy drive, which we got to do that anyways because you can't open this door. So I'll set you out of the way for now. I just want to get down to this motherboard. Yeah, you can really see it. I'm going to have to wash this board. In theory, that should just be the expansion of the ISA bus. So I don't know if they ever had expansions for these machines. I'm pretty certain though that they probably had a docking station where this thing would just slide in, and that was the expansion bus to the docking station. So the docking station would have like another floppy drive or a CD-ROM or something like that. Yeah. Yeah, it's the same button that the Macintosh has. Button. Yep. Let's see. What kind of caps do we have here? 1200 microfarad at 16 volts. Long life. There's an 1800 at 10 volt. The problem with these, I think is going to be the clearance. Yeah, because otherwise you're going to run into this board. So the height of these can't really exceed what we have here. So when we get replacements, we need to verify the height. Also, we got to wash this board because it's pretty bad. Yeah, it's bad. So let's continue taking this guy apart. Motherboard screws I want to put in here. Pest control guy will be here any minute. I got termites, guys. Termites. It's great. Very expensive repair that I don't have the money for. So I want to put that on a payment plan. Oof, gotta be super careful. Because the last thing I want to do is break those off. This has to come out somehow. Don't know how though. That's how. Lord have mercy. Come on. There we go. Oh yeah, look at this. You can see where it's leaked through the board, which means the vias are tainted. They've leaked through the vias and onto the board. Or this RF shield, I mean. Oh, God, that's so bad. Look at it. Oh, man. Really? Now, I've handled worse. But this is just bad. Squared. Yep, you can see the liquid on these transistors down in here too. Oh yeah, this thing has to get washed. It's really bad. And it stinks too. Alright. So, we're going to have to wash the board. Don't have a choice. I'm going to have to clean this up. Not that big of a deal. See, there's a spot there that there's these caps. It's on the caps, but the issue here is though that, well, I'm sure a lot of you understand, but the ones that don't, I gotta say this. The issue is epoxy is not perfect. Even though it looks thick and waterproof and all that, it's not. Epoxy will absorb moisture, just like concrete absorbs moisture. So this stuff will slowly get absorbed into the chips and transistors and will cause them to fail over time. Like if you work on these boards and you see the green crusties on the pins, and sometimes you clean it up but the chip doesn't work. The chip is dead, right? Well, that's why it's wicked up inside the chip. So that is a thing. All right, so the next part of this, I'm gonna have to clean up all of that and get the parts list written down somewhere so I know what I have to order. So that can get gracefully set aside. And then I need to look at the display and crack that guy apart and see what I got to order for that too. So let me do that. Alright, so now that I got the screen taken apart, I pulled the inverter board and LED board out, and yeah, they're leaking. And you can see it up under there. So that has to be done too. So that's two of them we have to take care of. But perhaps more importantly, I wanted to pull the panel out to see if there's any capacitors anywhere in here that needs attention. And I'm noticing right away one little problem. The panel is starting to delaminate. You see that little curly Q mess in there? That's the panel. Now, right now, that is outside of the pixel area, like literally right on the borderline. And it's impossible to see in the camera, but yeah, I can just see the line. Yeah, there you go. You see the border there? So I'm hoping that doesn't expand, and that's probably from bad storage conditions where this thing was baking a lot wherever it was. That is not vinegar syndrome with a bad polarizing film. No, that is not it. That is something else entirely. It's happening up here too. So it's entirely possible the polarizing film is bad. But judging by looking at it, that doesn't look like polarizing film to me. Issues. No, that's the panel itself, I think. But it is entirely possible the polarizer is degrading. You can kind of see it up here too. You see it up underneath the yeah, I'm trying to get it. Yeah, it's hard to see, but up in here there's some polarizing film or degradation occurring. It's only on that side too. Only on that side. So I'm gonna have to inspect that a little closer. It's not a showstopper because that is so minute and it's not even in the visible area. There's a little bit there, but you can see a couple dead pixels in there, and this is in the viewing area. So yeah, but having a dead pixel or two in an LCD is not all that uncommon. So not all that uncommon. So anyways, let's take a look at the screen and see what we have going on under there. Yep, that's what I thought. Right. Oh, come on, don't move. Right here. It's made out of the same brand capacitors that the one over here is, which is also leaking. So, are those leaking yet? I don't know. Doesn't look. Yeah, it is. You can kind of see it like right there. It's getting crusty. You can see them. Yep, those have to go too. Yeah, and recap aside. Oh well, is what it is. So we got our work cut out ahead of us. So we're going to have to get our capacitor list together and get this guy situated out. But I don't want to leave it resting on that because I don't want to cause any problems. So here's the one. It's the same brand here. I don't know what brand that is. That is Moran? I don't even know. But yeah, look at that. Gooey. Yep. Alright, well, I will be back in a jiffy. First, I got to get all the cap lists together, and then I got to clean that. I got to clean all these boards up. So, yeah, let's get our cap list built. Now, this has become a serious pain, so I had to literally rip these capacitors off the board just to get them out of my way so I can wash this thing because it's so bad. The problem is the solder is so corroded, even flowing fresh in there, I can't get it out. So we're going to have to clean the holes out as much as we can, extract the pins out of the holes, and then I'm going to have to take a drill bit to them, a very, very small drill bit, and I got to drill out the solder that is corroded. It's just not going to reflow, and I'm not going to be able to suck it out. Because all I'm doing is destroying and burning the board trying to pull these. So it's the only thing I know to do. But in the meantime, I got to go wash this board and get all of this spooge off of it. And it's actually burning my fingers. That's how acidic his stuff has gotten. It's pretty crazy. Alright, so these capacitor leads, I got the board cleaned up and I got the capacitor leads out. these leads were an absolute bear to get removed because of two big things really that we were fighting against. One, the corrosion of the solder joints, because these solder joints are so heavily corroded. I couldn't suck it out with that gun. That gun was completely useless. So I had to heat it up and pull it out and heat it up and pull it out. But the second thing working against us here is the thermal mass of the board, aka the ground plane. Because this is a multi-layer board. Matter of fact, you can see it right through here. You can see the traces in the inner layer. So this is a multi-layer board, of course. Now, the problem is it's taking all the heat away on top of trying to pull out the pins and all that stuff. So anyways, the solder is heavily corroded that the desoldering gun, even with the pins removed, is not sucking out, because you can see where I tried to do it here. The solder, it's not pulling the solder out. It's not going to happen. So what I'm going to have to do is I'm going to have to get these holes recessed as I possibly can with the desoldering gun, and I'm going to have to take a drill bit to these. Now, you've got to use an extremely, extremely small drill bit. You can't just use anything. Because what I have to do is I got to pull the old solder out with the drill bit, the corroded stuff, because it's not going to reflow, right? But you can't use too big of one, because if you're not careful, you'll go in here and destroy the plating and then break the connection to the inner layers and ground planes, VCC planes, and you don't want that. So you've got to really be careful when you're doing that. So I'm going to have to go through here and clean up all these connections and drill some holes in the old solder, and that way I can get the new capacitors installed. I went ahead and popped the battery apart. It's all ultrasonically welded in here, and this thing's a mess, of course. So, yeah, you can see the corrosion just coming off the cells. Now, I'm doing this because obviously this is part of the system cosmetically, so I need to get the cells out of it before things get really bad. But two, I'm going to save all the little proprietary bits off of these cells, like this little circuit breaker, just in case I want to rebuild the pack in the future. But what's amazing to me is this foam is not degraded, and the stickers are still intact. It's kind of amazing to me. This thing is 33 years old now, 34, I don't even know. Yeah, it's kind of crazy to think about. So the fuse is here, save that. And the only thing I'm going to do now is just kind of clean this up a little bit. Wash it out so this is all, not full of alkali or whatever this stuff is. But yeah, I need to save this, because this is a circuit breaker. This is a protection mechanism. Oh, I just don't know how to save it because it's spot welded in place. Nah. Best thing to do is, if I'm going to make a new pack, I could just move this down a little bit and re-tap it there. But yeah, I don't have a spot welder. But I'm sure I got to find out what cells these are. These are obviously nickel cadmium, nickel metal hydride, but they're 1.2 volt cells a piece, or 1.2 volts. But I got to figure out what the amp hour reading and all that stuff is. Let's see if it's on this thing. 2000 amp hours. So these are 1.2 volt, 2 amp hour cells. Just get a pack made if I wanted to make this. Otherwise, the other way I can do this too is I can shove AA batteries in there. Obviously, it won't last nearly as long, not even close, but it's doable. Alright, so I got all the capacitors in there. Now, these aren't the exact right values, because the issue is everything they used in this thing is oddball. But I got some close enough, like these 220s at 10s. I got some 220s at 16s or 25s, which are a little bit bigger, but they fit. So that's in there. I don't have the 56s at 35. I've only got 56s at 25, so I put 47s at 35 in here. Now, don't know how it's going to affect the performance yet. And I don't want to put any money into this thing until I know that it's, going to work properly. But anyway, so now I have a 1200 here, which is installed. Now, these two 1800s, I do not have any 1800s. I had a 1500 and a 2200, which is fine because these two electrically are in parallel. So if you do the math, that's 3600 microfarad, while 22 and 15 gives me around what, 37, so it's a little bit bigger, but it'll work fine. The only concern I have, these are the correct ones. This one's 100 microfarad higher because I didn't have any of these in low ESR, so I went one with a little bit higher, so we'll have to see how that works. And it's not, sometimes you can get away with that, sometimes not. So we'll just have to play that one by ear. Now this one here, it's a similar situation. I had to use a 47 to 35 versus the 56. Now here's another oddball, 120 at 16. I've only got a 100, so I'm going to put 100 in there. Now there's 10 microfarad at 25 volt low profiles that go here. Well, I do not have those. I've got 10 microfarad at 16 volts, piles of those, but no 25s. The only thing close enough in 25s are these 22s, which might be too big for this because they go into these chips here. Like that looks like a 555 timer. So the problem with that is if I put a 22 here, it may affect the timing of this chip because this is a 431, which is a shunt regulator, and this is a 555 timer, which is the oscillator for the inverter board. So if I just throw a random value there, it could, in theory, mess up the timing. So again, when you're substituting capacitors, of course you can just order all the right ones, but if you're just using what you have on hand, if you're going to substitute capacitors, you kind of have to understand the circuit design a little bit to know if you can actually get away with that or not. So in this case, I may not be able to, but I've got standard 10 microfarad at 25 volts, which are taller. I can probably fold them over. We'll have to see, because here's the issue. I could put regular caps in there, sure, but clearance. I've got to be super careful with that. Now that I got all the capacitors installed, I went ahead and did this board too. Again, I had to get creative there, so yeah, not ideal. But again, I'm not going to order a bunch of caps and invest a bunch of money into something that may not even work properly. So, plus I'm on a budget right now anyways, because now I'm going through termite treatment. Yeah, not cheap. Anyways, so now let's see if this board actually does anything at all. So I'm just going to connect this guy in. Find a grounding point. I don't know what it's going to do. It's either going to work or it's going to blow up. Does it draw any current at all? No. Let's see. Let's hit this button. Oh, it kind of tried to. It's kind of hard to do this with one hand. It's trying. Turns on and shuts right back off, but it is trying. And what I don't know, which I need to find out, is that secondary battery here. It may not run without that, because I know the early Toshibas, the very early ones, would not run without their main battery, right? So the later ones, I don't know, but the early ones would not. Just like the Apple Macintosh Portable. It just won't run without the main battery. Now, that is probably why the later ones would run, because this kind of substitutes what it needs to make it work. So, there's the sub battery and that's the main battery. So what I need to do is, here's what I want to do. I'm going to dial this down to 7.5 volts roughly. I don't know how accurate this is, so I'm going to go down more than necessary. So we're going to do the same thing. We're going to ground you, which actually that's probably not a good idea. Let me meter this out. Alright, yeah, it's definitely grounded, so let's see. It tries to come up, but then it shuts back down. Now, it could be because this is not hooked up, so alright, at least we're getting something. Nothing's blowing up. Alright, so I decided to grab the harness and screen assembly. I don't have the screen connected because it's not important right now. But I do have this board connected back in so I can see what's going on. So I have the 12 volts connected at this point. I have the DC light is on. It looks like, okay, now it's just light coming in. So let's power it on. Nope, it won't start. It will not start up. Nope. It just turns on and right back off. Yeah, so we've got a failure in the DC-DC circuit somewhere. Or there's a short in the board. I did plug this back in just in case, and I don't know if it's holding a charge or what it's doing. It's probably not going to. It's ancient as all get out, but yeah. So we've got a short somewhere in this board. And we need to figure out where that short is. So this is going to be a fun one. Because we don't have a schematic for one, but doing the finger trick at the moment. We don't have a schematic for one, but there is definitely something wrong in this board. So we need to figure out what, why, or how. Yeah, this is going to be fun. Alright, so I have already run a patch wire. You can't see it, but you can kind of see it between this cap. I already had to run a patch wire through one of the vias and solder it on both sides. But yeah. So let's do some more troubleshooting and see if we can't figure this thing out. Alright, I've been going at this for a couple hours now, and there's a few anomalies I'm running into. Like, for example, there's underneath, you can't see it, but underneath here, there's a MOSFET, or just a JFET, and it's trying to do this single-handedly, which is impossible. It's like there's a short. Yeah, it's like there's a short there or something, but it could be reading through an inductor. I don't know. But one thing I did find out right away, see this here? I removed it. There was a rectifier, a high-speed switching rectifier diode here, because I was getting a short across this capacitor, which doesn't make sense to me. So now that I remove that diode, if I go across here, no more short. Now if I look at the original diode, which is here, try to do this single-handedly, shorted. Alright, so that, on a standard ordinary body diode, you'd have the stripe. Well, the stripe would be right here. So that being shorted is not good. That's not going to allow it to come on. So we're going to have to replace that guy with, I don't know if I'm going to have that one. Chances are I'm not. I'm going to have to come up with something. But I'm going to have to put something here and see if that brings it back alive. So let me go in my stash and see if I got something for that. Alright, so I got a new diode in, and now this is totally overkill. But this is what I had on hand because I still had a stash of these from 2008 when I was servicing in-focus projector power supplies. I still have a bunch of these on hand. It's totally overkill. It's a 100 volt 3 amp high speed switching Schottky diode, but it's a high speed switching Schottky diode, so it'll work here. Alright, now hopefully there's no other faults with this board. Right? I can only get so lucky. Alright, so I'm set for battery voltage. Now, will this work or not? Nobody knows. Well, let's see. Now or never. Nope. Still shuts down. But hey, at least now that circuit's no longer a fault, so I'm going to go ahead and probe this, but I can't do that with one hand, so I'll be back in a minute. Alright, I think I'm getting closer. So I took that diode back off the board, Because I got to thinking, I'm like, okay, this still not producing any voltage. I'm thinking, okay, if that diode shorted, it had to have taken something else out that feeds that circuit. And I'm still detecting a short somewhere else. So I'm going through it. I removed the two inductors, so that way I can check underneath it, make sure no leads were burned off from the cap goo or whatever else. So I took that out. The short went away here, of course, because it's actually going through the coil. But if you look very carefully, see the drain goes into that one inductor. But if we look, see that nice hole blown into that? That 2SJ182 is blown to smithereens. That will certainly cause a problem, now won't it? So this thing has seen some destruction before me. So someone tried to plug this thing in and it just went whiz pow, and that was it. And they're like, well, time to e-waste it. So that's probably what happened. Someone tried to plug it in, blew it up because there's cap juice everywhere. So now I'm looking around to see if there's any more holes detonated into these transistors. I'm not seeing anything. I'm going to have to check because the source, since this is a 2SJ, that is a P channel. At least I think it is. That's going off into this resistor. Okay, so that means I need to check. Yeah, I do. I need to make sure that resistor didn't get blown apart. Because if that blew apart, no telling what it did to this resistor. Where is it? Was it here? Pretty sure it was here. Oh, this is so hard doing this one-handedly. No, not there. Where is it? No. Well, that resistor's not blown apart anyways. So I gotta find out, okay. You're going somewhere. Where are you going? I gotta pull that and figure out where it's going to check what's happened upstream. Because that's just it, I don't know. Because I can't just stop at the diode, which, I did, and there's more blown up. It's like, okay, well, I can't stop at the transistor either. I gotta keep going. Oh, that's a fuse. Never mind. Yeah, it's right here. Okay, yeah, I tried to suck out the fuse. Never mind. Yeah, that's right. Nope, it's not open. Alright, we're going to leave that alone. Okay, I'm going to have to try to spec that transistor out and see if I even have anything anywhere on a parts board. Alright, so I don't have the right transistor on hand. This is just a P-channel MOSFET. Now, I just threw a 9640 in there. It's not the right one, and it may not work at all, but I just wanted to try to get this thing hacked together enough to see if it's worth getting the right parts to fix it, to see if I can't at least try to get it to boot up, or even attempt to start up, because I don't want to throw a bunch of proper caps and transistors and diodes and stuff at it if there's some serious problems with it where it can't be fixed. So anyways, I got that hacked in there temporarily. Let's see what happens. Hey, it's on. It's running. Yes, it's running. Ah, yes. It's running. Ooh, it's kind of warm. Wow. Nice. That is... Holy crap, that's awesome. It is working. Okay. Before I start freaking out, I want to see what voltage that thing puts out. Negative 21 volts. Okay, so that makes sense. You know what that is? That could be why it blew up. Ooh, I need to check that. That negative 21 volts is the contrast or the VEE voltage for that LCD panel, because that is how that works. That's how those old passive matrix displays worked. So if there's a short in that, which we did see some leaky caps, if there's a problem with that, that could have been what knocked this out. So hold on, let me grab the thingy here. That could have been what knocked it out. It is entirely possible. So it goes to show you that the IRF 640 does work in that. Okay, here we go. It's on. Humming. I can't tell if it's trying to work or what it's doing. Let's see, what does this reset button do? Oh, that shut it off. Hold on. Yeah, it's executing code. It's running. Alright. Well, okay. So we can proceed to step 2. Let's get the right transistor for this, or something that'll sub in there. I don't know if through-hole D-pack transistors are made anymore. I don't know that they are. Surface mount ones are. They make them all the time. But through-hole ones, yeah, I don't know. But I can just sub a MOSFET similar to that in there. Even hell, the 9640 is working just fine, and it's cold. Yeah, it was probably warm from the soldering iron, but it's cold to touch. It's working fine. So I could probably use just about anything in there, really. Alright, so the machine is working. So now I'm going to take a look at the LCD. I want to make sure that that is not shorted, because if that is shorted, well, there you go. That's why that whole section exploded. Or it could have been from the capacitor goo. I mean, who knows? Someone could have plugged this thing in when it was soaked with fluid, which blew it up. Or it died in service, and then someone just was like, heck with it. It got thrown in storage until eventually it got taken to e-waste. Alright, we'll never know that story, unfortunately. But, alright, at least now I'm in a stage where the board is functional and I can work from that point forward. So, let's check that out, and I'm going to try that and see if I get anything on the screen. If I do, I'm going to call that a stopping point, and we're going to go ahead and get the right parts ordered in to fix this thing properly. Alright, so I checked the capacitors on the display. None of them are shorted. So I feel safe to be able to plug this guy in. So I just went ahead and plugged it back in. So I want to get it, kind of set out of the way. And, well, here goes nothing. Whoa! It lit up. Well, you can see the panel damage. Let's see. Oh, it works! Yes! It works! Holy crap. It's up and running. That's nice. That's nice. It works. Screen works. Good. So now I can justify getting the right capacitors, so I can get this thing done properly. I'm going to have to find the proper transistor for that too. Let's see if it's getting hot. No, it's not. Alright, well, who knows why it failed to begin with. It was probably the cap goo. Someone tried to plug it in and use it, and kabang. That's the only thing I can think of. Because there's a hole blown in that little there old transistor. That'd stop it from working, right? Alright, I think I'm going to break it off here. We're going to have another part 2 or something when we get all the right parts in and get all that done properly. So, in the meantime, thank you for watching. And if you have a comment, please feel free to leave one. And don't forget to hit the like and subscribe and all that fun stuff. And until next time, guys.